Common Core Regents Geometry Final, August 2017. So here we are on number 17. We're seeing this more often with reasonable questions, such as this one, partition a segment. What we're noticing is now they're starting to make these go off the graph potentially, or even at decimals. So it's trying to prep us, it's trying to make sure that we are able to understand it, not just graph it and use slope. So the concept that I want to show you here is we're just going to estimate where, I'd love to be able to graph it, but let's assume this is off the grid. Okay. We could go by twos, but that's also dangerous. So what I'd like to do is show you -8, -2 is somewhere in this neighborhood. 16.6 would be far over here. This is the idea I want to teach you. There's a change in x and there's a change in y. And you can get those from the coordinates. So you've got -8 to 16 is your change in x of 24. It's going to take 24 steps to go from -8 to 16. And then to go from -2 to 6 is 8 steps, which is your change in y. Now, when you look at a 3:5 ratio, we should be thinking 8 equal parts, right? So now here's what happens. We've got to take a change in x of 24, okay, but then split it up into 8 equal parts, which is 3 each. Change in y, which is 8. We're going to divide by 8 and get 1 each. That's for the partition, I should say. So this is kind of our y direction partition. Each, okay, and then this is our, this is our x direction partition up here, and our y direction partition there. So what's going to happen is basically from this point, we're going to go over 3, up 1, over 3, up 1, over 3, up 1. We're going to continue to do this until we get 8 equal parts. What we want to do is figure out the location for 3 of them. Okay, so I said, all right, what's 3 of these 3's? We're going to move 9. 3 of these 1's is 3. So I've got to move from here. I got to go right 9, up 3. I go right 9, up 3. So from -8, -2, I got to go right 9, up 3. All right, that's going to take me to 1, 1. Right? That's not easy to comprehend. There are other ways of doing that, but that's how I'm going to show it. All right. Number 18. So what we have is, we want to make KLM a right triangle. Oh, LN is the altitude, so that automatically is a right angle, because of the nature of altitudes making a right angle with the side it goes to. So, to make KLM a right triangle, we want to make that a right angle. So what we're going to do is we're going to have the 3 similar right triangles going on here. All right. So what we know is the sides, corresponding sides, I should say. That keyword corresponding. Sides proportional. All right. Now, we got to look at what sides we're talking about here. Okay, they give us KM. So there's a couple ways we can work with this. We know there's these 2 sides, and this one, those are related. Or these 3 sides here, the 16, whatever's there, whatever's there. So we've got a couple of possibilities here. LM, if LM is 13 and KN is 6, that would make this 10. Would that actually make this, would that actually make this proportional sides? So let's test it. I'd have to figure out what this is, okay? And I could use that Pythagorean theorem there, and then see if the sides work out proportionally here. So this is what I would do. Let's call this x. X squared plus 10 squared equals 13 squared. After some work here, I'm going to get square root of 69. Now, this relationship here is 6 is to x as x is to 10. X squared equals, when we cross multiply, 60. That's not going to work. So we know it's not this one. Now we're going to have to go through that whole process. And it wants to know which one's going to work. All right, let's try LM instead. Okay, so we tested out one, it didn't work. All right, now what if we test out LM? 12. NM is 9. We don't need that, but that leaves this as 7. Okay, let's test this out. So again, same process. 9 squared, oh, sorry, we'll do x. X squared plus 9 squared equals 12 squared. Do some work here. We get x equals square root of 63. Okay, so let's say we come over here. That relationship is 7 is to x as x is to 9. So we get x times x is x squared. 7 times 9 is 63. This is looking good. Take the square root. Get square root of 63. This is it. So that worked. The other ones won't. Okay, you can test them yourself. They won't work. They won't make the sides proportional for these three. So that's how it's going to work. All right, very good. Tough one, but we can handle it. Number 19. Okay, so what is supposed to happen here is sketch a right triangle. Angle A is 32 degrees. This is not drawn to scale. Should have put it down there. B is 90. And then we don't know what angle C is. What is the length of BC to the nearest centimeter if AC is 6.2? Okay. If we go relative to angle A, this is the opposite leg, this is the adjacent leg, and of course this is hypotenuse because it's opposite the 90. Now I go to SOHCAHTOA, my acronym for trig. I would select opposite over hypotenuse compared to 32, so I would want to pick, I would want to choose sine. So sine of 32 degrees, right, sine ratio defines the ratio of two sides, opposite over hypotenuse. Now, I would type sine of 32 in. This is just how I do it. Not everybody does it this way, but I would change that to a decimal, 5299 to 1. So now it's a proportion. And then cross multiply. X equals whatever 6.2 times that is. And sorry, calculator problems here. Okay, so it's coming out 3.2855, nearest tenth. So they want 3.9. All right, so we've got a density problem. They're telling us the density. That's people per square mile. All right, so what we're going to do is it's telling us, really simply, we can take our population, which is people, and divide. So you're going to want to do, for Florida, okay, what we're going to want to do is 18,801, 310, and we're going to divide that by 350.6. We're going to basically do that with everything. Illinois, 12,830, 632, divided by 231.1. New York, you're going to go 19,378, 102, divided by 411.2. Now, I'll get you those numbers in a second, and then we'll rank them. Okay, so here's what I found for the population densities. People divided by square miles gets us this, 53,626 people per square mile. Okay. Now, the one that's the highest is right here, the highest number of people, so the most dense, right? So you want largest to smallest. So Illinois got to come first, then Florida, New York, and Pennsylvania. It looks good. Choice 1. All right, next one is, in right triangle, the sine of some value is the same as cosine of another. That means the angles must add to 90 for that to happen. Okay, that's a theorem that we know. Cofunctions are equal when angles add to 90. So what we should do, and be very careful, it's an easy one to mess up here, is we should add them equal to 90. So this is 2x plus 40 equals 90, and we'll subtract 40 from both sides to get 2x equals 50. Divided by 2, x is 25, and there we go. All right, a regular decagon. You can plug it in too to check that, by the way, real fast. So is in fact sine of 15. I'm plugging 25 in here, right? Is sine of 15 equal to cos of 75? And feel free to go do that, right? 3 times 25 is 75. It will work. All right, a regular decagon is rotated n degrees about its center, carrying it onto itself. You should know that when we carry onto itself or map onto itself, we've got to convert that immediately to symmetry. Now, this is rotational symmetry. Specifically, sometimes there's line symmetry, but this is rotational symmetry. What we should understand is that means going around a circle. Now, a decagon would map onto itself every 36 degrees. Here's why. 360 divided by 10 sides, is 36. So every 36 degrees, the decagon maps onto itself. Now, if it ever asks us for the smallest number of degrees or minimum number of degrees, we'd report 36. That's not a choice, so it's kind of a trick question. What we then do is we look at all the choices and say, which one's divisible by 36? Well, 10 divided by 36, no way, that's not going to be a whole number. 150 divided by 36, I'm pretty confident that's a decimal. It's 4-ish. 225 is not going to work. Okay, now we look at 252 divided by 36. Now let me check that. I think it's 7. 252 divided by 36. Yeah, it is 7. So 7 of those 36-degree moves is perfect because it'll map onto itself. Very tricky question to a problem that used to be pretty easy. 2 more for this video. Circle with diameter 32. The area is, okay, so here's what I want to do. All right, so a circle has a diameter 32, radius is 16, area, is pi r squared. So the area of this should be 256 pi. I squared 16, left it in terms of pi. So the full area should be 256 pi. The area of the sector's 512 pi over 3. Now, what's the ratio of this, right? What's the ratio of this over this? Part over whole, 512 pi over 3 to 256 pi. Pi's cancel, I think that's 2/3. Okay, so 2/3 of 360, but that's not choice. 2/3 of 2 pi because there's 2 pi radians in a full circle is 4 pi over 3. Okay, tough problem, but that's what we're looking at there. That's radian measure of, what would it be, 240 degrees. Okay, next one. Find the equation of the perpendicular bisector of the line segment. So first thing we do is we have to go and find the midpoint. Okay, so it's 1, 2, 3, 4. The change in x is 4. 1, 2, 3, 4, 5. Change in y is 8. To find the midpoint, we've got to go over 2 and down 4. So there's the midpoint. Okay, so the perpendicular bisector has to hit the point 0, 0. Now, the key is the slope of, I'm going to call it segment AB. Currently, the slope of AB is, I've got a change in y of negative 8, okay, and a change in x of 4, so it's going to be negative 2 over 1. A perpendicular line has to have a slope equal to 1/2. So I need a line whose slope is 1/2 and y-intercept is 0. Now, none of these are of that format. Okay, maybe I could double everything, and maybe I could subtract this over. There it is. Okay, that's it for the part 1s, and hopefully this was helpful. Thanks so much.